Hello students, good evening all. So welcome to our sessions. So today in our today's session, we are going to start a new chapter guys. So today we are going to start with quadratic equations. So this is our first session in this particular concept of quadratic equations. So but basically we have covered some of the part like which is related to the complex thing that we have covered in our complex numbers. But apart from that remaining thing we can cover it here. So we'll be starting from the basic part of what is this quadratic equation, and then we'll be ending into the solution of it and then the nature of the roots and different things which are involved in with respect to the quadratic equation. So each and every point we are going to cover in our quadratic equations chapter. So first we'll just have as for our today's session, so we'll just have a quick overview of what and all concepts in detail we are going to study in our today's session of quadratic equations. So let's just have a look over here guys. So first, before starting with the equation, first we'll start with the polynomial, right? So first we'll see basically what is this polynomial and what is this expression, like how we actually represent it, how we actually write this quadratic polynomial. So all the aspects we are going to discuss here in detail. So once we are done with a quick detailed discussion about a quadratic polynomial, and then we are going to enter into our quadratic equation part. Right, so I am sure that you guys have already heard about this polynomials, equation, and basically what is the typical difference between a polynomial and a equation. Right, so you might have know the difference of quadratic also, like what will be a definition for this quadratic polynomial or a quadratic equation, right? So we'll just have a look over that also, right? So once we have cleared discussion about the polynomial, that is our quadratic polynomial, as well as the quadratic equation, as we have the equation, it's obvious that there will be a solution. Right, so solution is nothing but simply the roots are of the equation. So solutions are called to be the roots of the given equation. So once we have the quadratic equation, the next we'll be seeing the solution. So what are the roots of the equation? Right. So after the solution, there is one method called long division method. So if we are having two polynomials, one can be divided with respect to the other, right? So how we actually divide that polynomial is nothing but a long division method, right? So dividing the polynomial, we are going to look into that long division method, and then we are having a theorem here, that is nothing but a remainder theorem. So you might have heard about a factor theorem also, right? While we are dealing with the long division method, we'll be having the factor theorem, right? So using that itself, we are going to see this remainder theorem also, right? So basically this remainder theorem helps us to easily find the remainder when we divide one polynomial with respect to the other. So even using the long division method also, we can end up get the remainder by dividing one polynomial with respect to the other. And after these all the topics, as we have seen, we know that an equation will be having solutions or the roots. The next step will be how to find this solution or roots of the given quadratic equation. So there are different methods here we are having to solve any quadratic equation. So it can be a graphical point of view, it can be an algebraic point of view, right? So those methods of solving the quadratic equations we are going to discuss, right? So the very most familiar one which you guys might have aware of this methods of solving the quadratic equation is nothing but factorization. So if you remember, while dealing with our linear inequalities also, we have done the factorization of a quadratic equation or a quadratic expression, right? So the same thing. So that is one of the method of solving any given quadratic equation here, right? So right guys, so these are the concepts that we are going to cover in today's session of our quadratic equations. So let's get started with our session. So first we are going to start with quadratic polynomial. So basically, let me just give you what is a polynomial actually. So what is the general representation of any polynomial? So if I take some p of x is my polynomial, the general representation will be a into x power n plus a into x power some b, or else a1 here, a2 here, a2 x power n minus 1 plus a3 x power n minus 2 and so on until some constant an or something, right? So this is nothing but our general and standard representation of a polynomial. So now what happens here? What is a quadratic polynomial? So here if you observe, the x variable is having a power which is nothing but a degree, right? So whenever a polynomial having a degree 2, so a polynomial of degree 2 in one variable, right? So here we are going to discuss a polynomial in one variable, not a polynomial in two variables. So we are going to deal with a polynomial of one variable, right? So if we are having a polynomial in one variable with a degree 2, then that particular polynomial is called to be a quadratic polynomial. So in general, we can see the general form of a quadratic polynomial which is given here. That is, if I have taken my f of x is nothing but my quadratic polynomial. So the general form of this quadratic polynomial will be ax square plus bx plus c, right? So where a, b, c are nothing but they are all belongs to the real numbers, right? And here the coefficient of x square. So here what is the degree? The degree of this polynomial is 2, which means it's a quadratic polynomial. And here what is the leading coefficient? So the main degree coefficient will be the leading coefficient, which means here the coefficient of x square is a, which means here the a will be called to be a leading coefficient here, whereas c will be a absolute term, because there is no variable related to c here. It's a general constant term. So here c will be an absolute term here. So here we can see a is called to be a leading coefficient and c is called to be the absolute term of the given quadratic polynomial, right? So if our leading coefficient, so what happens if the leading coefficient value becomes 0? So let's take this. So this is our standard quadratic polynomial, ax square plus bx plus c. So here we are sure that a is nothing but the leading coefficient here. Yes or no? Right. So as a is the leading coefficient here, what happens if my a value becomes 0? That means my leading coefficient becomes 0. That means this entire term will become 0. Then my f of x will be remaining with bx plus c. So if the leading coefficient becomes 0, can we still call this polynomial to be a quadratic polynomial? Is it possible? No, right? So when the leading coefficient becomes 0, then what does it mean here? It actually reducing the degree, right? Then our main degree here turns out to be 1, which means this is no longer called to be a quadratic polynomial. Instead, here the degree is 1 for this given polynomial. It is called to be a linear polynomial, right? So, which means we have to make sure that when we are writing a polynomial, the leading coefficient polynomial, the leading coefficient of the polynomial can never be equal to 0. If that becomes 0, then there is no that leading coefficient, right? If the leading coefficient becomes 0, then the degree will be reducing, which means the polynomial will be another type of polynomial. Here we can see the example itself, right? As the leading coefficient a turns out to be 0, our polynomial has been turned to be linear polynomial here, right? So this is the quick discussion about our quadratic polynomial. So basic, what are the important steps here in our quadratic polynomial? Any polynomial with degree 2 is called to be a quadratic polynomial, and the leading coefficient here, which is a, cannot be equal to 0, right? So this is our second important point, and our constant term or absolute term will be c. right? So that's why whenever we are writing any type of polynomial, the leading coefficient cannot be equal to 0, right? So let's see what is actually a quadratic equation, right? So when any quadratic polynomial, so that is any quadratic expression, right? Any quadratic polynomial expression, if that actually equated to 0, then it turns out to be a equation. So basically what is the equation? Anything equated to 0, right? So here as we are equating the given quadratic polynomial expression, if we are equating that to 0, it turns out to be a quadratic equation, right? So let's see. So initially what is our quadratic polynomial? We have seen ax square plus bx plus c. So this is our quadratic polynomial, right? If I make this polynomial ax square plus bx plus c equated to 0, then what is this? So this is called to be an quadratic equation, right? And what about these x values? So whatever the x values satisfying this quadratic equation are called to be zeros, either zeros or roots of that quadratic equation, because for equation we will be having some sort of solution, right? So that's for sure. So when we have a equation, there will be a solution. So what are actually solution called to be? So whatever the variable values which are satisfying the corresponding equation. So here it's a quadratic equation. So what and all the values of x which will be satisfying this given quadratic equation are called to be roots of the equation or zeros of the equation, right? So this is about our quadratic equation. So now you might have understood the difference between what is a quadratic polynomial and what is a quadratic equation, right? So now let's see the general form. Here we just discuss in detail what about the terms here, what and all the coefficient are called to be. So everything in detail we'll just discuss for our quadratic equation. So general form of quadratic equation is nothing but ax square plus bx plus c equal to 0. So this is my general form of any quadratic equation, right? So as we have discussed here, what is a? A is the leading coefficient. So a is the leading coefficient, and there is one more condition, that is a cannot be equal to 0. So in every polynomial, the leading coefficient cannot be equal to 0. Right, so if it is a quadratic polynomial, the leading coefficient will be the coefficient of x square. So a cannot be equal to 0. Similarly, for cubic equation, it will be different. It will when the power degree is 4, so it will be changing. Right, so here a cannot be equal to 0. And if you see, what about b here? So b is nothing but it is the coefficient of the middle term. That is, we can call the b here as a middle coefficient. And what about c? C is our absolute constant term. So that will be a constant term here. Right, so if we are having any general equation, quadratic equation, ax square plus bx plus c. So what about a is a leading coefficient, b is a middle coefficient, and c is a constant term, and a cannot be equal to 0, as well as all these three a, b, c will always be belonging to the real numbers. So these are the conditions you have to be make sure for any quadratic equation. So in general, we have discussed as the general form we have considered here, ax square plus bx plus c is equal to 0. So now let's discuss about the roots of an equation, right? So the values of variables. So just now we have discussed what is the root of a equation, or else what is a solution, what is the zeros of a equation. So those are nothing but the values of the variable. So if I am having ax square plus bx plus c equal to 0, so the solution of this equation is nothing but the values of this x variable which are satisfying this given quadratic equation. So those values are called to be roots, we can say zeros, we can say solution, we can say, right? So how we actually get that? By taking this f of x that is equal to 0, right? So the real roots of this equation are the x coordinates of the point where the curve intersect the axis, right? So you guys already might have known how to find the solution of a quadratic equation. So how you'll be finding? You'll be trying to use a factorization in a very easiest method, right? So apart from that, even by looking into the graph, by plotting the graph itself, we can actually get the solution, right? So again, when we are talking about roots or solutions, there will be two chances here. So there can be real roots or there can be complex roots. So we already have a great idea about the complex roots as well as the real roots. So when you are studying in your lower sections, it might be difficult because you haven't learned about the complex. Right, so now you are aware with both real as well as complex. So now it will be a bit easy. Right, so if we plot this on the graph, and then we can actually, by looking at the graph itself, we can predict the roots, which are the solutions. So how can we say that? So whatever the x values which are satisfying the curve, which means when the curve intersecting the x-axis, so those points will be the solutions of the quadratic equations. So let's see the graphs and understand it. So the graph will be different based upon the coefficients here as well as the discriminant also. So let's see our general quadratic equation, that is f of x is equal to ax square plus bx plus c equal to 0. So let this be my general form of quadratic equation. So now my first case here, so let's take this to be my first case where my leading coefficient is greater than 0 as well as my d. So what about d here? D is nothing but the discriminant which is given by b square minus 4ac. Yes or no? So you might have aware of this discriminant concept, guys, because in 10th you will be having a discussion about this particular topic. So there is nothing new here. So yeah, so the new part here is we'll be looking into the graphs. So here the leading coefficient, the first case will be where the leading coefficient is 0 as well as the discriminant also 0. So when discriminant is greater than 0, it's sure that, so when discriminant is greater than equal to 0, what about the roots? They'll be real roots. If it is less than 0, then there will be imaginary roots. Right, so here if a is greater than 0 as well as discriminant is greater than 0, then the graph will be intersecting the axis at 2 points, which is x1 and x2, which means the solution for this graph will be, the roots will be x1 and x2. Right, so here when a is greater than 0 but the discriminant is equal to 0 here. When the discriminant is equal to 0, the graph will be intersecting the x-axis at only one single point, which means we know here we'll be having two roots, but both the roots are equal here. Right, so as it's a quadratic equation, we know that as the degree is 2, there will be two solutions here. Right, so here when the discriminant is equal to 0, both the roots will be equal. That means x1 equal to x2 here. Right, so what happens if discriminant less than 0? If discriminant is less than 0, we won't be having any real solution. That means the graph will never intersect the x-axis. Right, if it is greater than 0, discriminant is greater than 0, we'll be having two solutions. So that's why two distinct solutions. Oh, in precise if we talk about, for the first case, we'll be having two distinct solutions. So that you can see x1 and x2. So in second case, you can identify, here we'll be having two equal roots. That means both roots are equal, x1 equal to x2. In third case, there are no real roots here. That means there is no solution here, no real solution will be having for the third case. So this is our first three cases where our leading coefficient is greater than 0 as well as discriminant greater than 0, discriminant equal to 0 and discriminant less than 0. for the same discriminant, we can have another 3 cases where the leading coefficient is less than 0. So let's get back to those and see, have a look here. So here, this is our general form of quadratic polynomial, right? So if this is my quadratic polynomial, so now my fourth case here, which we are going to discuss, is my leading coefficient here is less than 0. So what I am having here? So I am having my leading coefficient that will be less than 0. And along with that, so for all these 3 cases, I am having my leading coefficient that will be less than 0. Along with that, I am having my discriminants. So discriminants will be having 3. Discriminant greater than 0, discriminant equal to 0, as well as discriminant less than 0. Right. So if discriminant is greater than 0 and my A is less than 0, the graph will be something like this. As the discriminant is greater than 0, I will be having 2 distinct real roots. So I will be having 2 distinct real roots which are given by this x1 and x2 here. Right. So these are my solutions here of this quadratic equation x1 and x2. So initially when our leading coefficient is greater than 0, the graph will be upwards, whereas if it is less than 0, the graph will be downwards. So that is the difference we can see when the leading coefficient is greater than 0 and less than 0. So whereas for discriminant greater than 0, it is obviously every time it will be 2 distinct real roots. When it is equal to 0, it will discriminant equal to 0, it will be 2 equal roots. And when the discriminant is less than 0, there will be no real roots here. So the only difference is when A greater than 0, we will be having upward graph. When A less than 0, we will be having the downward graph. So along with the discriminant also, you can see what are the roots here. So for the fourth case here, x1, x2 are 2 distinct real roots, and for next case 2 equal roots, both will be here, x1 equal to x2, and here the graph is never going to intersect the x-axis. So here we won't be having no solution, no real solution, right? So by taking the leading coefficient as well as the discriminant, we can actually predict the nature of the roots, like how many roots we'll be having, whether they are distinct roots or equal roots or no real roots. We can actually predict that even by looking at this graphs. So if a polynomial is given, as we have seen the solution, so how we'll be finding the solution? So if for suppose I am having a quadratic polynomial ax square plus bx plus c, that is nothing but ax square plus bx plus c equal to 0. So this is my quadratic equation, right? So what will be my solution? Suppose if I am having my R1 to be a solution, right? So then R1, as R1 is the solution of this quadratic equation, it has to satisfy the equation, which means a R1 square plus b R1 plus c, this should be equal to 0. Yes or no? Because solution itself, the definition of solution is nothing but it has to satisfy the corresponding equation, right? Which means if this is my root, then what about my factor? I can write this as x minus R1, right? So what it states here is, using the root, we can actually get back to the polynomial, right? So if for any given polynomial R1, R2, R3 and so on until Rn, if these are the roots or solutions of that polynomial, then that polynomial y can be written as some constant into x minus R1, x minus R2 and so on, x minus Rn. That means here R1, R2, R3 and so on, Rn are nothing but my roots, and this x minus R1, x minus R2, so these are all nothing but my factors, right? If I have my R1 to be a root, then the corresponding factor will be x minus R1, right? So I can write my polynomial as my product of the factors. That means if R1, R2, R3 and so on until R1, if these are my roots of the polynomial, then my polynomial can be written as the product of the factors. That means a into some constant into x minus r1 into x minus r2 into x minus r3 into and so on until x minus rn. So this is from the factors, that means from the roots itself we can write the polynomial, right? So now we are getting into our, so far we just had a quick introduction part, like what is a polynomial, what is the representation of it, what is a quadratic polynomial, and then what is a quadratic equation, and what are called to be the roots or zeros of a quadratic equation, and how the behavior of graph will look like, graph of a quadratic equation will look like basing upon the leading coefficient as well as the discriminant of the following quadratic equation. So these are the concepts which we have covered so far, right? So now we are entering into the division of polynomials. So that is nothing but, we can say it here, it's a long division method, right? So let me give you a numerical example. So let me take a number 13 and I am going to divide this with 5. Right, then it will be 5 into 2, 10. What is the remainder? 3. So this 5 is called to be the divisor and 2 is called to be the quotient and 13 is called to be the dividend and 3 here is remainder. So when we actually stop this division, until my remainder is either less than my divisor. Right, so when my remainder becomes less than divisor, until that step I am going to divide my given equation or the given numerical repeatedly, right? So here how will we represent this 13? So here according to this division, my dividend will be equal to divisor into quotient plus the remainder 3. Right, so my dividend here will be equal to divisor into quotient plus remainder. So this is nothing but my factor theorem we'll be calling. So by dividing the any number, we'll be writing the factor theorem which is given to be here, that is dividend equal to divisor into quotient plus remainder. So this is not only valid for the numericals, it will be valid even for the polynomial. Right, so how it will be? So let's see that. If I am having my polynomial f of x, which is a dividend here. So I am going to divide this with the factor x minus r, which is a divisor. Right. If I divide my dividend with this factor, it's obvious that I'll be getting some quotient here. And after doing it here, I'll be having some remainder. So this remainder can be a polynomial or it can be a numerical. But the degree of this remainder should be less than this. So the degree of the remainder should be less than my degree of the divisor. So that is the only thing, like how we do for numericals, the same thing will be applicable here. So same as for the numericals, we can write it here, that is what is our dividend here? Dividend will be f of x. So dividend will be equal to divisor into quotient. So what is the divisor here, guys? X minus r will be the divisor. So divisor into quotient. So what is the quotient? So quotient is q of x. So divisor into quotient plus the remainder. So this is our factor theorem, we can say, and this is our long division method which we will be using to divide the polynomials. Right. So let's do a question, guys. So I hope you guys have a quick idea of it. So let's take 2 to 3 minutes and first you give it a try, guys, and then we'll look over it how to do this division of polynomial, dividing the polynomial using this long division method. So can you guys give it a try? So take few minutes and give it a try, guys. So I will guys trying. So here what is our polynomial? So given polynomial, let it be f of x is equal to 3x square plus 5x minus 8. So this is our dividend here. So 3x square minus 5x, sorry, plus 5x minus 8. So this polynomial has to be divided using this divisor, which is x minus 2. So let's see guys. So here to divide, we have to eliminate our first term, that is x square. Right. So to get the x square eliminated, I have to get my quotient here. So my divided has to be multiplied with what term? That is 3 into x. Right. So if my x minus 2 is multiplied with 3x, what it will happen? So 3x square minus 6x. Right. So my coefficient here will be 3x. So here what will be my term? 3x square minus 6x. So what we are trying to do is we are trying to eliminate the terms first, slowly, one by one. So this will be eliminated if we subtract and if we add. So this will be 6 plus 5, 11x, and the remaining will be coming here. Right. So now here the coefficient is only x, but here we are having 11. So let's just multiply with 11. So now what will be my term here? X minus 2 into 11, which is equal to 11x minus 22. Right. So that will be substituted here, 11x minus 22. Again with minus, this 11x will be getting cancelled and we'll be having plus 22 minus 8. Right. So into minus 8, that will be plus 14. Right. So as here there is no power, which means here there is no variable. So we can stop at the division here. So now what is the quotient which we are having? Q of x, that is equal to 3x plus 11. And what is our dividend? Dividend is given to be 3x square plus 5x minus 8. And what about the divisor? So divisor is given to be x minus 2. And the final remainder which we are remained with is 14. Right. So this is how we'll be dividing any given polynomial with the given corresponding polynomial using the long division method. Right. So let's move on to the next one. So the next one is nothing but remainder theorem. So just now we have seen our factor theorem, which states that the dividend will be equal to the divisor into quotient plus the remainder. Right. So if we take the x value equal to r, that means how my expression will change here. So my r here is nothing but my root or the solution of the equation. So now according to my factor theorem, I am having expression something like this. X minus f of x is equal to x minus r into q of x plus r. So if in place of x, I am going to substitute my root, that is f of r. Then what it will happen? R minus r here and q of r here plus r. So anyways here r minus r, which will become 0 and it remained with only r. That means f of r is equal to directly the remainder. That means if we are going to divide with the factor x minus r, right, so instead of doing that whole long division method to get the remainder, what can we do? We can take this root, that is x minus r equal to 0. That means x equal to r will become my root. And now I can directly take this r and substitute in my given equation, and that value will be directly my remainder. So that value will be directly equal to my remainder. So this is called to be my remainder theorem here. That means if I am having a dividend x minus r, which I have to divide my given quadratic or any polynomial, right? and then I have to find the remainder. So instead of doing that whole long division method, what can I do to get my remainder easily? I'll take this r value, right? I'll take this root value, the solution or the 0, and I substitute in the polynomial, and that corresponding value will be my remainder. So that as simple as that. So let's see a question, guys. So here comes a question. So now we'll just understand. So by doing two methods. So here how we'll be finding a remainder. So we are having two methods. One is the long division method, which we have seen previously, and the other is remainder theorem. So we can apply both of these method and we can get the answer, that is we can get the remainder, right? But this is a lengthy process, whereas this will be a easiest one. So let's see the questions by applying both of this and see how it will result here, right? So first we'll read out the question, guys. So by using the remainder theorem, determine the remainder when 3x cube minus x square minus 20x plus 5 is divided by x plus 4. So quickly apply the remainder theorem which we have seen just now and get the answer, get the remainder, and then we even see using the long division method after the remainder theorem. So come on, guys, what is the dividend here? So our dividend given to be, that means our f of x function is given to be 3x cube minus x square minus 20x plus 5, and our divisor is given to be x plus 4. That means what is our r value? So in general our dividend will be x minus r. So what is my r value from here? R will be equal to minus 4. So how we will be finding the remainder? My remainder will be equal to f of r will be equal to capital R remainder. So simply substitute the r value in the given polynomial and you will be getting the remainder directly, remainder value. So come on, guys, it's just a substitution and then you'll be getting the answer. So let's just see by substituting. That means our r value is minus 4. So this will be 3. So in place of x, we have to substitute that. So minus 4 whole cube minus, again minus 4 whole square minus 20 into minus 4 plus 5. Right. So first thing here, minus 4 whole cube. Right. So minus 4 whole cube will be again minus. So 3 into 16. 16 4 64 here. Minus here 4 square, as the square minus will be eliminated. So 16. So here minus into minus plus 20 into 4 80 plus 5, which is equal to, again we have to find 64 into 3, which is minus 192 minus 16 plus 85. So 192 minus 85 and then plus 16, which is equal to minus 123. So this will be the remainder, guys. So what is the remainder value which we are having? That is minus 23. Right. So instead of doing our complete long division method, we can simply use this remainder theorem and we can get easily the remainder value. So let's just have a quick look using the long division method also. So what is the dividend here? So 3x cube minus x square minus 20x plus 5. So this has to be divided with x plus 4. Right. So here it should be 3x square so that we could get x cube. So x plus 4 into 3x square, which is equal to 3x cube plus 12x square, guys. So it will be 3x cube plus 12x square minus, so both will be eliminated. So here plus minus, so minus 13x square and remaining will be coming down minus 20x and plus 5. Right. So next what we are having, so the next thing here which we are having is minus 13. So it should be minus 13x. So x plus 4 into minus 13x, that is minus 13x square minus 13 into 4, which will be 52x. So minus 13x square minus 52x, guys. So plus, this will be getting cancelled, minus plus, that means 52 minus 20 will be 32x plus 5. Alright, so the next thing which we should have here is plus 32. That means x plus 4 into 32. Right, so 32 into 4. So 32x plus 32 into 4 will be 128. So 32x plus 128, which means again minus here, again minus here. So these two terms will be getting cancelled and it will be 5 minus 128, which is minus 123. So if you remember what we get, the remainder using our remainder theorem, which is equal to minus 123. The same value which we got using the long division method also, but the two different methods. So the easiest one we can use. So basically remainder theorem. So unless if they mentioned you to follow long division method, you can go by the remainder theorem and you can get the remainder value. So let's do few questions related to this. So this is one more question, guys. So quickly try and read this question and do it and let me know what's the answer. Take your time. Take 5 minutes. So let's read the question. So what's the question they have given? Find the remainder by long division method and by remainder theorem. So now we have to solve this question using two methods, both the methods which we have discussed, long division as well as the remainder theorem. So I'm looking for the answers, guys. Just text me in the comment section. So those who end up getting the answer, you can text me in the comment section. I'm just looking for the answers. Quickly, guys. So those who have finished solving this, guys, please let me know the answer. Come on, guys, did anyone finished it? Let me know quickly. So here, what is the dividend, guys? So our dividend f of x is given to be 2x power 4 minus 10x square plus 30x minus 60. So first solve it by remainder theorem and let me know the answer, or else you can go by long division method also, as your wish. Quickly, guys, quickly do it, solve it. So very simple question. So just the same procedure how we have solved the previous question. You just have to follow the same steps here. So let's choose the long division method first, guys, and simplify it. Let's see how it goes. So this, let me erase this first. Okay. So 2x power 4 minus 10x square plus 30x minus 60. So this has to be divided with the given divisor x plus 4. Right. So here if you observe, it is x power 4. So it is x. So what will be our coefficient which we have to multiply? It will be 2x cube. That means x plus 4 into 2x cube. Then what will be the result? 2x power 4 plus 8x cube. So 2x power 4 plus 8x cube. So minus here, this will be getting cancelled and this will be also minus. So here if you observe, for the previous one there is no cube term. So we are reminded with only cube in the new one, right? So now you will be having a new term, that is minus 8x cube and then minus 10x square and then plus 30x minus 60. Right, so now what is the coefficient? It will be minus 8x square. Right, so x plus 4 into minus 8x square. So this will be 8 into, so minus 8x cube, and then minus 8 4s are 32, so 32x square, right? So this will be plus, getting cancelled, right? And then it will be plus again. So plus 32 minus 10, it will be plus 22x square. So plus 22x square plus 30x minus 60. So far we are remained with 22x square plus 30x minus 60. So let me erase this, guys, or else I'll just do it here. 22x square plus 30x minus 60. So now what will be my next coefficient term? It will be plus 22x, right? So then it will be 22x square, and then 22 plus 4, it will be 88x. So minus, eliminated, minus here, so it will be minus 58. So minus 58x minus 60, right, guys? So now we should be having only minus 58 here. So if we multiply with minus 58, so this will become minus 58 and then minus 58 into 4, right? So 58 into 4, what will be the value? So let's just multiply. So 58 into 4 will be around 232, guys. So if I add, this will be eliminated. So 232 minus 60 will be 172. So finally the remainder value will be equal to 172, right? So if you remember, if you see this procedure, it took me around 3 to 4 minutes to do this long division method in order to get our remainder, right? So now if we follow our remainder theorem and find the remainder, so let's see how simple it is and how minimum time it required by using this remainder theorem. So the answer will be the same, right? So let's check it. So here x plus 4 is the factor given, so our r value will be minus 4. Yes or no, guys? So let's substitute. So f of minus 4 will be equal to minus 4 power 4 minus 10 minus 4 square plus 30 into minus 4, guys, minus 60. So now we are having 4 power 4, so it will be even, so it will be positive only. So 4 into 4, 16 4 so 64. 64 into 4 will be 256 around. So 2 into 256 minus, so here 10 into 4 4 so 16 minus 120 minus 60, right? So 256 into 2 will be around 12, 10, 11, 4, 5. So 512 minus 160 here minus 120 minus 60. That means 512 minus 160 minus 120 minus 60. That will be nothing but the value again equal to 172, guys, here also, right? So if you guys see the thing here, how much time it took? Around 1 minute, even less than that, right? So that's why if in the question, if it is not mentioned that we have to do the we have to find the remainder using the remainder theorem or long division method, if it is not mentioned, you can simply follow the remainder theorem and you can get the remainder of the given division, right? So far we have discussed our introduction part, like we have started with quadratic polynomial, then we have jumped into our quadratic equation, then had a discussion regarding the roots and solutions as well as the graphical representation of the quadratic equations according to the leading coefficient, like when leading coefficient is greater than 0, what happens when leading coefficient is less than 0. So those are all the things we have discussed, and after that we have discussed our division method, that is long division method, and after that we have even covered our remainder theorem, right? So we have done the corresponding questions. So let me give you some questions for homework, guys. So here it's a question, you can take this question for homework. So you can just give it a try how it will go. So let's take this question as homework. And if you guys have any questions and any queries, you can ask me whenever it is possible. You can just text me in the text box, and then I'll just try to give it to you as soon as possible. So we'll just end up our session with this discussion of our remainder theorem and long division method. So in our next session of quadratic equation, we are going to focus on the methods of solving the quadratic equations and the nature of roots and any different kinds of things which are involved in it. So that will be our aim for the next session, which we are going to discuss. Right. So now you can just work it on with this, guys. You can take this question as homework, and you can let me know if you guys have any questions, any problem with solving this is with that. So that's all for today's session, guys. So we'll just cover the rest in our next session. So mostly we are going to discuss the methods of solving the quadratic equation. We are going to start with that particular concept in our next session of quadratic equations. So thank you, guys. Thank you, everyone.